let's talk about some examples where you aren't explicitly told what is the initial and what's the constant change. Yeah, so here's an example with the movie rentals. Fill in the table and write an equation describing this linear relationship. Okay, you rent 2, it costs $18. You rent 4, $24. Ooh, how many does it cost, or how many do you get for $27? How much does it cost for 7, 11, and how many movies did you get to rent for $66? Okay, well, this seems kind of awkward for me. So what I'm going to do is maybe over here, I'm going to make a new table of values, one that helps me. I'm going to call this N for number of movies rented and C for cost. Now I'm used to going like this to figure this out. If we rent 2 movies, then that costs $18. If we rent 4, that is $24. Okay, so I'm noticing we don't have our initial because usually that lines up with 0 rented movies. And we also don't have our constant change. You know, things are a little bit, I don't know, like erratic. So let's see if we can work this out. To go from the 18 to the 24, 2 increments are made. And also, let's see. So what's the difference between 18 and 24? Is that 6? Yeah, $6 difference. Okay, so we have a $6 difference for 2 more additional movies rented. Okay, and so as a ratio, let's see, I think that's $3 for 1 movie. Okay, well, there we go. So I use these 2 different given amounts in order to find the actual constant rate or the constant ratio, which is plus 3 plus 3 plus 3. Let's see if that actually works out. So 18 plus 3 would be 21. Okay, so then the question is, if it's $3 per movie, here we go. I'm going to backfill this too. How much plus 3 makes 18? 15? Okay, so here is my pattern. $3 a movie. How much plus 3 makes 15? At 12? Okay, so it looks like there's an initial fee of $12, an initial cost of $12, and then it's $3 per movie rental. Okay, well, if that's the case, so let's actually write that down. Write an equation describing this linear relationship. I see that the initial amount is $12. So if we had rented 0 movies, then it still would have cost $12. I'm guessing that's like a monthly fee, or I remember I used to have these at some time for some subscriptions at different places. So there's an initial fee of 12. Let's see here. Okay, so for our equation, cost, which is our response variable. So I'm using this right now, right? Our response is cost. Our initial is $12 plus the constant change times the explanatory. Okay, so the cost is equal to the initial $12 plus $3 for each movie. I guess we could have put an M for movies rented. I'm going to do that. Instead of number of movies, I'm going to call it M for movies. So initially it's $12 and then $3 for each movie. Okay, so let's see how much this would be. Well, if we had, $12 of this is the flat fee. So that would leave 15 bucks, and that's for 3 movies. 15 bucks for 3 movies means you rented 5 movies. Okay, so filling in this table, 5. Oh, and that makes sense. Look, it's 3 additional more dollars, so it's 5. Oh, from here to here, that's 2 more movies, so we have to add 6 bucks. $27 plus $6 is what, 33? 4 more movies. Well, 4 movies would be $12. So 12 more dollars would make that what, 45 bucks? Got it. Let's suppose you spent 66 bucks. Oh boy. Okay, well, $66, and 12 of those dollars were the flat fee. What does 66 take away the flat fee? 54 bucks. So that's 54 bucks spent, and it's $3 per movie. How many times does 3 go into that? 18. Okay, so this is 18 movies, 66 bucks. And how much more is that? From 66 to 72, is that 6 more dollars? So that's 2 more movies. Got it. Okay, so fill in the table actually required me to create a new table where I just went 0, 1, 2, 3, 4 in order to find the constant change in the initial. And once I figured out how much it was per movie, then I could move on from there. What is the slope of the line? And say what it means. The slope of this line is 3. And by the way, that's the same as the constant change. And what does it mean in the context of this situation? Each movie rental is $3. What is the y-intercept of this line? Excuse me. The y-intercept is the same thing as the initial. So that's $12, also known as the initial. And what does it mean? Well, there is a fee of $12 before renting movies. Or maybe in order to rent movies. Does it make sense to use negative x values here? Okay, and so when we look at this and it says x, my mind says, we don't have any x's, you silly Willy. So, or in my house we call it Silly Lily because my daughter's name is Lily. X is taking place of the explanatory variable, which is an m in our situation. Does it make sense to have negative number of movies rented? No. No. We do not rent less than 0 movies. Okay, so it doesn't make sense to go negative here for the number of movie rentals, but in other scenarios, it definitely could. So, couple of quick remarks. Let's go green. In order to write the equation of the line, you need the initial value. To write an equation of a line, you need the initial value which is also called the y-intercept. And sometimes in order to find that initial, so in this scenario we weren't given either the constant change or the initial value. Oh, my alarm is going off. And so sometimes we're going to need to use the constant change. So if we don't know the constant change, we use the amounts given to find it. Then we use it, the constant change, to find the initial. So up here, we used two different values to find our constant change, and then we use that to backtrack to get our initial value. In the next video, we will look at this third example to finish this section.